Alright, now we're gonna do something a bit harder. We are still gonna use the P's and the Q's to double check whether our answer is true or false, but we are going to be using the true or false answers themselves to figure out what else is true and false. Okay, so we continue with T, T, F, F, T, F, T, F. Okay, so how do we tackle this? So as you can see, I changed the question around and made it a bit more complicated. So now the question is the disjunction of Q and negative P is the disjunction of Q and negative P with the conjunction of Q true or false? So we have to figure that out. How do we do this? Okay, well, first we determine what the main operation of this statement is. And as we can see, the negation of P is in parentheses, and the negation and disjunction of P are in parentheses, while the conjunction is not. So that means the conjunction is the main operation. So that will be what we find last. Okay, complete the columns of the simple statements and then their negations if they are relevant. Okay, so how do we do this? So we take Q right here, and you see that Q is just Q, no negation here. So we T, F, T, F. And then we see Q here, T, F, T, F. But then we see the negation of P. So whatever P is in the simple statements, it is its opposite. Okay. And now we remember that this is not just a simple symbol, but like a full statement, a full compound statement. So what this is saying right here is the full statements of Q, the disjunction of Q and negative P. Is this true or false? And to do this, we are going to, we're still going to do our double checking with these guys. We're just going to figure it out with the table. Okay, so what do we know? What do we know? So the disjunction. Okay, when is it true? And when is it false? Okay, so it is false when both Q is false and P is false. It's true any other way beside that. Every statement has to be false for the disjunction to be false. So, what do we see here? We see that while the negation of P is indeed false, Q is true. So that means that the disjunction is also true. Okay. And what do we see here? The negation of P, it's false. The negation of Q is also false. So we know that the only way a disjunction can be false is if all of its statements are also false. And this is true. So disjunction is false. Okay. As we see here, both of the statements are true. The disjunction is true. One of the statements is true. One is false. It is true. Okay. So we figured that out. So now it becomes, how do we figure out this conjunction? Okay. We're running out of space, so bear with me. Okay. How do I do it? Okay. I'm just going to erase some stuff. Okay. So what it's asking us is, so right here, it's asking us, is the entire statement, is this true or false? So for example, it's asking us So it's asking us, is Q or the negation of P in conjunction with Q, is this a true or false statement? And let's find it out. Okay, so what do we know about conjunctions? Okay, so they are the and. So unlike the or statements, both of these have to be true. Okay, so for it to be true, both Q plus P have to be true. And for it to be false, anything else aside from that, it is false. So if Q is false, then it's false for the entire thing. If P is false, it's false for the entire thing. It's in direct contrast to a disjunction. Okay. Alright, so what do we know? We know that the disjunction of Q and negative P is true. And we know that the conjunction of Q is true here. So we know that both of them are true, which means that this statement as a whole is true. Okay, so let's look at this as an example. So, alright, so we have P and we have Q. Okay. Alright, Q is 8 plus 4 equals 12, and P is 3 squared equals 9. Okay, so we look at this. Okay, so 8 plus 4 equals 12 is a true statement, so that doesn't change. But the negation of P is a false statement, so 3 squared does not equal 9, so this is false. But remember, as a disjunction, only one of them needs to be true for the compound statement to be true. So this entire thing is true. Alright, so there's that. Now the question becomes, what about the conjunction and the Q? How does that work out? Alright, so what do we know? We know that the Q in this example is also true. So the Q, as remember, is 8 plus 4 equals 12. Okay. So we know that the disjunction, which I will represent with T, because it is true, T and 8 plus 4 equals 12, both of those are true. So because both of those are true, the conjunction itself is true. I hope that made sense. Alright, but yeah, that's how you work it out. Okay. Alright, so as we can see here, it's just a row of F's. So, what do we know? We know that for a conjunction to be true, both of the statements have to be true. And what do we see here? We see a false, and we see a false. That's how we know the conjunction is also false. We can work it out like so. Alright, P, Q. 3 squared equals 9, 8 plus 4 equals 12. Okay, so. Okay, right, where was I? Right. Alright, 8 plus 4 does not equal 12. And 3 squared does not equal 9. Okay, so, since this is an OR statement, one of those has to be true, neither are. The disjunction is false. Okay, so we automatically know that the conjunction is also false because the disjunction is false. But let's continue. Okay, so 8 plus 4 does not equal 12, as the Q is also false. So now it comes to false statements, and 8 plus 4 does not equal 12, which is also a false statement. So the conjunction is false. Okey-doke. Alright, and what do we see here? We see the disjunction is true, and the Q also true. So that means this is true. Now, we see here that the Q is false, like so. But the disjunction is true, but we remember that both of them have to be true for the conjunction to be true, so this is false. So yeah, that's how you solve a slightly harder truth table. I hope this helps, and I will come back at you with another harder example that we can work through.